Anyone seen the problem yet?
Yeah, the first one's there.
So Amy, if you look up for a sec,
1, 2.
we're going to go 1 on AD minus BC. We're going to swap them, we're going to make them negative, and we go 1 on 0. So does that have an inverse? So, because when you get a 0, and you know that concept, if you get a 0 on a denominator, you know how many zeros will add up to 1. Is that what you're asking?
No, why is there such thing as when you have an inverse?
I know.
The inverse.
When we create a system, which is, remember, originally they just created a system and they said, you know, this is going to store information. They're going to do calculation. They make up a system. The system ended up with, when they created an inverse, 1 on AD minus BC, ended up with some of them had no answer.
Oh no.
Yeah.
Oh.
But you know, a moment ago we were doing cos graphs and we said, where did the cos graph get to 2? And it didn't get to 2. So you think there's an answer, but there isn't. You think there's an inverse, but it isn't. So what tells us if it's singular? AD minus BC. So what's the rule? If AD minus BC equals 0, it is, yeah? Singular. What does singular mean? It really does not exist. But is it does not exist? Because people don't talk about does not exist for matrices. They talk about it has no inverse. So we'll go further on that. So 3. Calculate. Now we go to the next step. Now Matt, this is where people get wrong in the test. They go, I know the rule, and they go for the brainwash you and everything that leads up to this. Brainwash. So Josh, we have one rule about singular. There it is. Joshy Josh. So, do that. So Matt, I talk about triggers. It says singular. Will your brain remember at the next test that I use AD minus BC equals 0? Okay, for this to be singular, we need to get its inverse. No, start again. We do it properly. No, we're just going to do it this way. We're going to get the determinant. If that was A, that'd be a little bit fussy. The determinant of A is AD minus BC. So we go AD, which is x squared, minus BC, which is 16, and we have to let it equal 0. So if it's singular, we let it equal 0, so x squared equals 16, and x equals
4.
So for a million years, feels like a million years, I wrote plus or minus 4, and every...
If you write only 1, do you get like that?
Yeah.
Really?
Yeah, because there's 2 answers.
Oh,
So I don't think I've ever had a senior class where every kid on any one assessment wrote plus and minus. I don't think so. So how common is that? So I wrote that. So then I started this, what's clear, this is what happened to my brain. If I wrote plus and minus, it didn't work in people's brains. I started saying a squared can have 2 answers because it's a parabola. So if a parabola can have 2 answers, so is this a parabola? How many answers can a parabola have? 2. Might have 1, might have none, but it could have 2. So that's going to have 2 answers, a 4 or a. I was doing that to hope that kids will start remembering these 2. First it's a parabola, second it's got 2 answers. Because every time I nagged about square root, you've got to write plus or minus. The people didn't work. The interesting part is that some of you will say, I never ever forget that.
I don't think I've done it in a test at least.
So this one will be, if we call it A, let's go a little bit formal. Determinant of A is AD minus BC. So we're going to go 9 by 2, which is 18. I can just write that down. Minus BC, which is 2. Oh, I went 2x cubed. I've done yucky. So that's good that I've done yucky, just what happens. We all let it again. 2x cubed is 18. I jumped to the right number, didn't I?
Yeah.
X cubed equals 9, so x is the, that's okay. Cube root of 9 is going to be about 2 by 2 by 2 is 8, so it's going to be about 2.1. Remember I was talking the other day about being able to rough estimate things? So I know my brain just goes 2 by 2 by 2 is 8, 3 by 3 by 3 is 27. So we want it to be 9. It's probably not even 2.1. Yeah. Imagine they say to you in an assessment in Year 12, now mark it on the graph.
What's the cube root of 9?
Oh, 2.07.
The cube root of 9 is approximately 2.088888.
Oh,
no.
You were close.
Close. So what have we got now? X plus 3 times x plus 2 minus 2 times 1 is 2. Yeah? And to be singular, in other words, no solution. We're getting to it. Here's the super part. We're getting a solution of what will be not a solution. The singular has no solution, but we're finding out the values of not a solution. So what have I got, Josh? Expand that for me.
X squared 2x, 3x, and 6.
Minus 2 equals 0. And I've got x squared plus
5x
plus.
plus 4.
You know what? I flipped it first go. Instead of thinking about it, I just wrote up some numbers that look logical. And I got it first go because that's going to be x plus 1. Now, do you have to show that in exams? No. Ben, talk about formality, what you need to show. So if you wrote that down, you went, oh, that's that, and you just wrote, and then you went x is minus 1 or minus 4, full marks. I still want to do this with you. Now we've got those answers. Oh, maybe this will be like we did in trig earlier on. Might be a couple here. Jordan, Amy. Well, it turns out if we, that maths, this math says if we put a minus 1 there, we won't be able to get an inverse. So let's go x and minus 1. What's a become? Minus 1 plus 3 is 2, and it's a 1, and it's a 2, and say
1.
a 1. And we got AD minus BC is 2 take 2 is 0. So you're right now. And if the next equals minus 4. So these are the only two numbers, or that pattern of numbers, that won't give us a singular matrix. So there's an infinite number of solutions if I use that pattern. Except for minus 1 and minus 4. So what have we got for minus 4? Minus 1, 1, 2, and minus 2. Am I right? Yeah.
Correct.
So that'll be 2. Take 2 is 0. So that will be singular, but all we knew we had